Alrighty. We got a very long question that's pretty messy, so I would say let's just dive on in. Our statement reads, we have a car that travels along a 45-degree line in S at ordinary speed 2 over the square root of 5 times c. Alright, again, that's a fraction of c, so we will have to do the relativistic regime. A. Find the components ux and uy of the ordinary velocity. Find the components eta x and eta y of the proper velocity. C. Find the 0th component of the forward velocity, eta naught, and then in system S bar, we are moving in the x direction with ordinary speed, square root of 2/5 times c relative to s. By using the appropriate transformation laws, part D, find the ordinary velocity components u bar x and u bar y in S bar. E, find a proper velocity eta bar x and eta bar y in S bar. And then F, of course, as a consistency check, verify that eta bar is equal to u bar over the square root of 1 minus u bar squared over c squared. Holy moly, we got some work to do. Let's get started. Alright, so what we need to know, of course, are the transformation rules. Again, since we're traveling or transforming in the x direction, that's going to be the biggest thing. But as far as how the proper velocity transforms, that is this first bracket. The 0th component, again, has a time or a signature that is more time oriented, so we have to be careful with that. So that's why we have this system here. Again, this is just how the 4 vectors transform. First component, assuming we're moving along the x, and then the other 2 remain unchanged, so we're good there. So y, z. How the velocities transform, well, we had to deal with that a couple times already. But of course, we have like the Einstein velocity rule for x on x, but then we have to be careful here for the gamma factors in y and z. Yeah, so let's just be careful with that, and let's get started. Let's first draw out our diagram. Again, we were told that in S that we were moving on a 45-degree line at speed ordinary velocity 2 over root 5 times c. So to find the x and y of this, that should be pretty quick within this, and then we can plug those in to find eta. So let's go ahead and get that started. The first part should be pretty quick and easy. I would say it's the last part that's going to get us hung up. So for part A, from the diagram, we see that ux is equal to u cosine 45, and as expected, we get this 2 over root 5 or 2 over root 5c, and then cosine of 45 gives us root 2 over 2. The 2's cancel as we see canceling out. And then we can combine the square root because the square root of 2 over the square root of 5 is the same as one singular square root. And likewise for y, since it is a symmetric line, we're good to go there as well. For b, since eta is defined as 1 over the square root of u squared over c squared times u, we need to know what u squared over c squared is. Clearly, if we square either of these, we're fine to go. We get 2 over 2 squared over root 5 squared, so that gives us 4/5 c squared. So as you see, the c's cancel, pretty much as expected. And then we just push on through for that gamma term there. So we see that we get a root 5u, and since ux equals uy, we see that the proper velocity coordinates for eta x, eta y is equal to root 5ux, and so ux being the square root of 2 over 5 times c, the root 5's cancel, and we're left with root 2c. So you kind of see we get these definitions over and over again. This setup is not too bad. What we're going to have to do next is kind of messy, so let's bear in mind all we have here and keep a good bookkeeping, so to speak. Alright, so for part C, we're looking for what the 0th component was, which was a c over the square root that we have here, and that's still easy because we remember that from last time. 1 minus 4 over 5 led to us the square root of 5, so we're good there. And we see that we get the root 5c. Now, D is where we have the transformation starting to come in. We note that since we're transforming an S bar relative to S in the x direction, we just need to use the Einstein velocity rule. And of course, naturally, we chose it to where, or the problem chose it to where they would cancel here. So our transformed x component is equal to 0. Okay, that's wild. Now for the y, this is where things start getting gross really, really fast. Here we have uy over gamma, and then times 1 minus v u x c squared. Here we know that v is the velocity between the two frames, and ux is what we found in part A. Gamma here we have to be careful because that is the square term of what we're moving with, v over the c term, so let's just be careful in how we simplify this. The gamma gives us the square root here, this gigantic mess. You notice that we're squaring this term, so the squared c's cancel. Similarly here in the parentheses term from the v and ux, we get a cancellation of c's again. Everything's starting to get tidy. So here, the square here undoes the square root, so we're left with 1 minus root of 1 minus 2/5. We still have the 2 over 5c in the numerator there, but here we have root of 2/5 times root of 2/5, so we just get a 2/5 there. And as you see, this simplifies to 3/5. This simplifies to 3/5. So since we're dividing by 3/5, which is 3/5 to 2 over 2 power, this square root cancels, and we can see that here with this red, we reduce it back to a square root. The reason why we do that is because now we can combine these square roots and cancel the 5s in both of them, and show you that we have, since we have a fraction in the denominator, we multiply by the reciprocal, all under the square root, and that's what gives the 5s the cancellation there. Nonetheless, we see that we're left with root 2 over, or the root of 2/3 times c. Again, kind of nasty, to be quite fair. E then, we have to use the transformation rules after just finding a to 1 and a to naught in the previous term. So for a to 1 or a to x, we see that we have 1 over the square root of 1 minus v squared over c squared, that old thing from the gamma term. And then we have a to x minus v over c a to naught due to the substitution of beta. And okay, there we go. Now let's plug in all the facts that we know now based on everything. We get this familiar looking square root. That was found, so we see that we cancel, and then we're left with a root 2c and then a root 2c. There we go. This simplifies down, of course. And then we can flip that because we're dividing by a fraction, but because this is the same thing and we minus them, we get a 0. So they transform to 0. Makes sense? The other two, of course, are going to transform as such because we're the velocity is moving in the x direction from c bar relative to s, or s bar relative to s, not c. So they stay the same. So we still have our root 2c there. Pretty cool. But what this shows is that if we're trying to verify that eta bar is equal to u bar over the square root, let's plug everything in and see that it holds true. That being said, that denominator gives us a root 3 times u bar. Let's see if this actually holds for the two factors we have here. Is it true that eta bar x is equal to root 3 u bar x? Well, anything times 0 gives a 0, so we're good to go there. Check. And then y, that stays unchanged. So you see here, we plug in what we found for u bar y, cancel, and we're left with exactly what we expected, root 2c. So yep, we are actually good to go. As messy as this is, so long as you can keep everything in a nice order and put everything where they need to go with the respective transformation rules, everything's pretty straightforward. Like I said, it's not. I wouldn't say it's difficult. I would say it's messy. So be very careful with your bookkeeping.